Welcome to Vintage Radio Cafe, your #1 channel for relaxing vintage audio restoration. If you like watching an idiot wielding a soldering iron, you've come to the right place. Watch Ray's attempts to fix wonderful forgotten radios from another era, way before transistors. Sometimes he even gets them working again. What could go wrong, right?
Good morning, everyone. 9 a.m. Friday morning. As you can see, I'm all set up to start working, actually doing electronic work on the Grundig. Got all my capacitors. Some I had to order. Vacuum tubes though, I had, out of the 9 I needed, I had 7. So there's 2 that I still have to replace. But first of all, I just want to make a, I'll try to make it short. I just want to make a video, show you what I've done so far, what's my progress. And I'll start with the cabinet and point out the mistake that I make, or the misevaluation. As you can see here, see the difference? I thought this brass or this metal was just gold plated somehow, but it's solid brass. And I've cleaned this part, as you can see, the difference. I thought oxidized brass would turn green, but it's probably the stage before green. It's sort of pinkish from handling it with our hands, our fingers. So that's good news. I'll be able to do it all over the radio. So that should come out pretty good. Same for the control knobs. As you have seen in the previous footage, they were so tarnished, it was incredible. So the chassis has been completely cleaned, and I have to tell you, it wasn't that bad. As you also saw in the video, most of the muck and the grease were on those 2 tone control wheels, most of it. The rest was just dust, and getting a small compressor really made a big difference. I worked maybe 4 hours on it instead of my usual 8, 9, 10 hours cleaning it. So okay, so that's the first part. As I already said, the fuse was blown, well, or corroded, and I had to get a new fuse. So since you have access to all the 4 voltages on this type of radio, it's just a matter of putting the right fuse in the right spot. And for the 125, which is the voltage I'm going to be working with here, that's what I'm going to be using, I'm supposed to put a 125 volts AC fuse with a 1.2 amp current. And would you believe, here in Canada, I was unable to find 125. So I had to settle for a 250, but it makes no difference because that's the voltage. What's important in a fuse is really the current. Okay, so that's that. So also the EM34. What a beautiful vacuum tube. Beautiful. But of course it won't work. It's so old. The problem I had trying to find one is that it's the first time I see this. They're not only are they not produced anymore, but you cannot find them. Anybody that has some to sell on eBay, well, they tell you either it's not working or it's weak. One guy said 80%, but you know, and they're asking crazy prices. I'm not going to pay $100 for something, you know, it's supposedly 80% good. Okay, before I get to the filter can, I just want to show you this. I pulled one of the electrolytics from the chassis at random. This is C83. It should be a 50. It should be a 50 microfarad. Look at that. Look at that. That's 54% out of spec. So there's no reason the other ones, the other electrolytics, should be any better. And like I said before, even if they gave me a good reading on the meter, I would still change them. So my work today will be, trying to do the recapping. I do not recommend shotgunning a radio ever, like I'm about to do. Okay. Well, at least I'm going to change all the electrolytics, okay, including the big filter can. I'll check the B plus path before I start, with the multimeter. I'll check as much as I can, but I know I'm going to be changing it. And in this case, well, the can sits on top. So before I remove it, because I'm never lucky with those cans, it's always the same thing. There's always a tab or two that breaks. This was from the previous Grundig, from the 2220. And I had kept it whole because I wasn't going to use it because one of the tab had broken off. But I cleaned it, I gutted it yesterday, and as a backup. So if I really mess this one up and I break all three tabs, I'll at least be able to use this one. It's the same diameter, but it's a bit shorter. But the new electrolytic caps I'm going to be putting in are going to be much smaller. So they should both fit inside if worse comes to worse. Okay. Other mistake that I made when I was explaining how the FM were working, I was saying there was just one tuner for the FM. Well, I was wrong. And when I pulled the chassis out of the radio, this is what I found. Okay. Right on the FM can. And as you can see, there are two wheels to control those two separate FM tuners. So there is, in effect, only one FM band that's being broadcasted. Different wavelengths, different station, but there's only one band. What this does is give you access to one and access to the other tuning, if you will, the tuning strings. So if I press this one, FM2, and I move the tuning dial, you see the bottom one moving. Okay. And if I depress FM1, it will be the top one moving, right? Easy. And if I use any of the medium wave or short wave, then we'll see it move. So got this figured out. One other interesting part of the radio, like I've mentioned before, the ferrite antenna compass or indicator here is backlit. And I'll show you when I move the radio around, but I had trouble finding those. Those bulbs are 6 volts. I think they're 0.1 amp, something like that. 1 watt, 6 volts, 1 watt. Anyways, I think they're called BA7s. Anyways, they're the right ones, perfect, with the 2 little flanges on each side. Okay, and where I found those is from a company here in Canada, in British Columbia, called CP. It's California Parts Import, so CPI 1 in British Columbia, and they specialize in auto parts for restoration. They actually specialize in Volkswagen parts. So those, as you can see, are also known as dash bulb. So they were used in dashboards on the old Beetles, or maybe some other models of Volkswagen. So I thought that was really interesting. So let me turn the radio around and I'll show you exactly where that bulb is supposed to go. Now you see the backside of the chassis, and as you can see, it came out really clean. I gave a couple of coats of varnish on the transformer. What I want to show you is where the little light bulb goes. Took me a little while to figure out how it works. Let me go here closer. Yeah, so here you have the front, here we're at the back, and the bulb just goes through there, and the indicator is on the other side. But what threw me off is those screws on each side. But actually, that's for the whole assembly. What you need to do is, simply push this down. This little tab. Yeah, this little tab here. And this releases the bulb. Easy enough, right? Okay, so the two bulbs that I have to change is the EBC 41 here, which is a new one for me, and the EF80, also new for me. So the EF80 on the vacuum tube tester is low. This one I can't test. I can't test because I don't know in which socket it goes or what setting to put the the vacuum tube tester on, because it doesn't appear in my chart. I have like 3,000 tubes I can check, but this one I have no information for. So I went and looked it up, and this is the EBC41, and it says it's an AF amplifier, used as AF amplifier. So okay, the audio frequency. So if this one is gone, I probably won't have much input, if any. And the other one, the EF80, they say it's an RF pentode. Pentode intended for use as RF, IF, or video amplifying. Okay, so we're not in video, we're not in TV, RF, IF. Radio frequency, intermediate frequency. So it doesn't have to do with the audio, really with the radio frequency. So, okay. Other problem. I've shown you the EM34. Okay, I'll try to show you from here. So the EM34 goes here through the chassis. Problem is, since I cannot find any EM34s, I'm going to try, because I've seen it, I'm going to try to use a Russian 6E5, either an E5S or E5C, and I'll try to adapt it. The way this works, this is the, actually just put it on the side. This is the socket that goes to it. It's not an actual socket, it's just a phenolic wafer with the contacts on. But since the tube is already quite long, I've got maybe this much room, but there's a solution, okay, to use the Russian, and I'm going to show you the Russian tube. This, I've seen a guy, don't remember in which country, on YouTube, using one of those to do the conversion from the 6E5C to the EM34 socket. I think that will solve the problem of the grid voltage difference, because I'm told, now I spoke about it with David, and he says that the 6E5 has a lower grid voltage, so the tube, the indicator might be too bright, might be burning out. So either I put the proper resistor to ground on the grid, or I try one of those. I've seen a guy do it, and it seemed to work perfect, but I'm not 100% sure. But that's the idea. And if we look at the, this is the, yeah, that's all I could find. Either it's in Russian or I have this for the 65 and the EM34. I have more information, which will give me a base, to calculate the voltage drop if I have to with the Russian tube. So that's going to be a problem, or I'll have to find a solution for that. Let me show you the underside and show you the work I want to do today. Oh, I forgot. Before I turn the radio around, I just want to show you the plate, the back plate. It came out really good, but as you can see, it's really yellow. But I can tell you this, in this particular case, I am not going to try to remove it. It's really, really, really complex. With all those tuners there and all those strings, I'm not going to take a chance. It's clean enough now. I'll try it. And if I find that the light coming out of the display dial is the glass is too yellow, I'll just put a piece of vellum paper or something. Yeah, so it won't be permanent, but it'll give probably a whiter light. Maybe it'll look better. So that's a possible solution, but I'm not going to repaint it, not even by hand. Too complex for me. Here is the underside of the chassis. And as usual, I've already marked all the paper capacitors I want to change, as well as the electrolytics. Yeah, this one here still has to go. That's the 10 microfarad. And I already replaced C83, the 50. So this is what I have to do. At the very least, replace those caps. And I want to show you the can. So here's the can and the underside of it. I really don't know if I'll be able to show it to you, but there's only 2 capacitors inside, so there's 2 contacts. There's 2 red wires going to 1, and from this there's 3 resistors. So it's pretty crammed up. On the other connector, there's only 1 gold or yellow wire, and on one of the tabs, just want to focus, yeah, on one of the tabs, which is negative because the can is negative, so the tab is negative, there's 1 wire going there. So what I really want to show you is just how much they are bent. Those, I don't know if it's in focus or not. Maybe I can, yeah. So you see it's completely twisted like 90 degrees. So once I put heat there to remove the wire, to get rid of the solder, it becomes refriable. It's not flexible, well, not much anyways, and I have to try to de-twist it. Same for this one here. Where am I? Sorry. Can't even see my, yeah, this one here. It's not all the way 90 degrees, but it's pretty twisted. But there's nothing soldered to it. So maybe I'll be able to untwist this one. This one is 90 degrees. So it's a lot. You can see the little tab here underneath the wire. This is what holds it in place. And it breaks from there. So I'll try to do that. I'll come back when I got the can out. With any luck, it'll work. But I'm not sure. All I can say is once this is done, that's 50% of the work. The I said this before, the rectifier is also a can. I think it's a thinner aluminum. I think it's going to come out more easily. I would like to gut it and put one of Manuel's board inside, if I can. I'm not sure I'll have enough room, if it's going to be wide enough for the size of the board. It seems to fit just putting it on top, but I really don't know the thickness of the can. So I'll be back when I'm done with that. Wish me luck. Catch you later. Okay, so after a few hours of working real hard, I managed to remove the can. And let me close up without breaking any tabs. Either I was lucky or the metal is a little bit different. I didn't heat up the where there was a ground wire there. I didn't heat it up too much. I ended up cutting the wires on the actual contacts, so I didn't have to heat up the can too much. Maybe that's why they didn't break off. So now I'm wearing gloves simply because just here there's not much lettering left, and if I don't put gloves, it's going to disappear, whatever's left. It's not as good as the other can. Let me show you the difference. Yeah, there's more lettering on the previous one, and you can also see how shorter it is, maybe half an inch, something like that, 5/8. But it's my backup if I screw up something. So now what I have to do is to grind, and I don't have a belt sander, so I'm going to be using a Dremel. I have to grind the top all the way around so I can remove that part of the aluminum can and remove the base. Yeah, I did it with the other can. I should be able to do it with this one too. So let's try this. Got my safety goggles on, of course. I don't think I'll be able to close up as much. Well, maybe I can go halfway. Something like that. Yesterday I used, what speed was I on? I think I was between 4 and 5. Something like that. Let's try that. Let's see if it's fast enough. So after 4 or 5 passes, you get to the point where the metal starts to give. Here, you just test it with your screwdriver, and at one point, the material is thin enough to just come off. So I can just pry the rest with a screwdriver smaller than this one, and the ring should come off. Yeah, not now, but soon. See, there's already a gap here. Oh, let me do that. So okay, just running the screwdriver between the wall and what was left of the material, it freed up the ring, and it's a good opportunity to take a look how those are built. So when we say the can is negative, this is the contact. It's just a foil that goes just underneath that ring and makes the whole can negative. and the two positive are just connected there to the two connectors. Simple as that. But now there's a rubber ring, and then there's that's the base to remove. That can be very hard. You can actually break it. It's not too bad here. Sorry for the movement. Maybe a little bit close. There you go. Something like that. At this point, you have to break this. There you go. This is done. Have a better view of that negative contact. Okay, now I'll work on trying to remove this. You could try to pull directly from the connectors, but I don't recommend it. They're too soft, they might break, so you have to loosen it. I sometimes use WD-40 just to penetrate on the side. It usually helps. So let me do that. So at this point, the phenolic and rubber cap comes loose, and you can clearly see the two contacts here for the positive. This one's broken off, okay? But you see the other one complete, and you just have to remove that, and now the fun begins. The idea is to remove this. Is it dry? Yeah. It's very, very hard. It's only a little bit humid in the center. All the exterior is really dry, and that's why you change those electrolytics. Yeah, I won't do it on camera because I know it doesn't work the first shot, but you can try. Yeah, we'll do this off camera. Try to grab it and twist it, but usually comes off in chunk. Yeah, so see you in 2 hours. Well, we just might be lucky here. I drilled 2 holes about halfway down the can, and I'm using long nose, curved long nose, and it seems to be, yeah, wanting to come. I might not get the whole chunk at once. But maybe then, maybe I will. Wow. Well, I was lucky today. So this is what it looks like. And it smells pretty strong. It smells like new electronics, actually. But really, really strong. So I'm going to clean the can and buff the edges to make it smooth with sandpaper and 4-aught steel wool. And after that, I'll show you how we restuff them. So, okay, here we are. We have all the parts we need to do a restuffing of this can. This is some of the material left over from the grinding, which we can toss from the top of the can or the base. So this is the can, and I just, sanded down the base, so it's pretty straight, pretty leveled, although all this part here is going to be folded over the base with this and the rubber. You get the picture. So I have a few options here. We know the can has 2 electrolytics, 250s. We know the can is negative. It says negative polarity for the casing. We also know on the schematic that the both electrolytics share the same negative, which is the ground. It's a -2 ground, so it's the same ground. So what I need to do, first of all, I use 56. I should it's supposed to be 50s, okay? If I get 47, I've said this before, if I buy 47s, they can be as low as 20%. 20% low, so that's, you can get, if you're not lucky, you can get 42 microfarads. So I prefer to start with 56. Usually they're lower. This time, just to contradict me, they weren't higher than 56, but they were close to 56. So I measure everything before I start, and I'm going at 5603, 5491, 5602, and 5506. So I'm going to take the 2 weaker ones, and I'm thinking, I'm going to put them, the contacts are going to be like that, the positive, but they're going to be reversed because I'm going to be using one of those. Those come with Manuel's boards exactly for that, but to put outside of a can, I'm going to use it inside of the can. So I'm going to be putting one capacitor on one side, one capacitor opposite on the other side, and the ground, both grounds will come here, and from there I'll run a wire to the can, or to, because I could also do that. Yeah, that's true. I could also use a 3 connector and use one of those connectors for the ground, but I don't like to do that because it's too close for comfort. So I'm gonna just run a wire. Maybe I'm thinking, like I did before, drill 2 holes here, and the wire will just, be inside of there. But I'll be sure that the whole can is negative. Although it's, the contact from the can to the tab that's going to be negative will be only guaranteed by the metal folded over the can. So you have to be really, really sure when you do that. When you fold the metal, you fold it enough to have good continuity. Of course, I can check it before I put it on the chassis, but that's the idea. There's different ways of doing it. I'm thinking of doing it like that. It's not complex because there's only 2 connectors, because there's 2 electrolytics, so you just have to be careful that your positive never touch, and it's the contrary on the negative. They have to be joined together. So supper time now. Pulled pork is in the oven, so that's enough for me today. I started at 9. It's I don't know, 5, it's 6 o'clock. I didn't work at it all day because I was interrupted all morning, but I certainly put 3 hours into this, and as I always say, I'd rather take my time and do a good and safe job than to try to rush and break some records. I have nothing to prove. I'm doing this for my own pleasure. So stand by. I'll be back once this can is done. Hopefully I'll do it right. After that, we can install it, and after I change a couple of paper capacitors, maybe we'll be able to do the first test. Oh yeah, and also forgot. Since I got this maybe 2 years ago, it's a thick, heat-resistant tape, non-adhesive. And I was thinking, since the can is going to be much wider, it is much wider than the capacitors. Well, once they're joined in the middle, this is a little bit bigger. So I was thinking of using a strip of that and just making a groove and wrapping it around the board, so it should fit snugly inside. I'll put something at the bottom so it doesn't wiggle, doesn't try to move. But that's what I'm thinking now. So catch you on the flip side when I'm done with this. So okay, I'm back. It's the next day, end of the afternoon. Supper's in the oven again. Would you believe it? I worked on it maybe 3 hours, whole afternoon, just refolding the metal over the can. And I did exactly like I said I would. I put the two capacitors like end to end using the little board I showed you. And I did the can, I rendered the can negative exactly like I said with a wire, but I didn't test yet. So first test is to see if I get continuity between the tab and the can. Let's try this. Continuity mode. Hope it works. It'll look really stupid. So touching one of the tabs and the can works. Another tab. Okay. So this means the continuity is good between the ground wire from the PCB inside, and the continuity is good between the ring holding those tabs and the can. So far so good. Now I have to see if I get a reading. So I'm measuring one of the capacitors now. 5478. Great. Let's try the other one. $56.13. 55.96. You know, it's moving a bit. So it's pretty close. You know, the connection seems to be okay. Let me show you a little bit closer the result. Moving closer. So from the bottom, the can, you know, it doesn't look so hot. You see all the metal here, although I did polish it and grind it. But since it's going to be sitting flat on the chassis, nobody will know. And the wire I was talking about is here. This is the thing. So I drilled two little holes. I passed the wire through. I came back in, and I, you know, with the lead, the extra lead that I had, I just twisted it together, pressed it against the can. But this alone makes enough contact to get a good continuity. So the tabs are hopefully strong enough for me to reinsert them in the holes on the chassis and start redoing the connections. So, like I said, with a little bit of luck, because I'm not sure it's going to work, they might break off, although I only need one making contact. And since, like I said, since it's going to be flat, if you know, I'm really bad lucky and I break two, I can always put a dab of hot glue or epoxy. But I'll do my very best not to break those tabs. I'll be back when I'm done with that. Okay, so I'm gonna try to reinsert the can here. Hope it goes in. Wow. Okay. It fits perfectly. I'll try to twist one of the tabs in the same direction, but very slightly, just to hold it in place. Temporarily. Okay, I'll do the rest off camera because it's really delicate work.